The learning objective.
Water hardness is concentration of metal ion expressed in the terms of milligram per liter of equivalent calcium carbonate. Primary ions are calcium, magnesium, and also iron and manganese.
Alkalinity refers to the capability of water to neutralize acid. This is really an expression of vaporing capacity. A buffer is a solution to which an acid can be added without changing the concentration of H+ ion without changing the pH appreciably.
pH. Potential of hydrogen is a scale of acidity from 0 to 14. It tells how acidic or alkaline a solution is. More acidic solutions have lower pH, more alkaline solutions have higher pH. Substances that are not acidic or alkaline, called the neutral solutions, usually have a pH of 7.
Now in our aquarium, several biological processes are responsible for reducing and increasing the pH. For example, nitrification is a vital biochemical pathway which is responsible for the oxidation and detoxification of ammonia to nitrate. Because this pathway generates the release of two free protons, and because it's happening 24/7 in high amounts, it can be responsible for lowering the pH. On the other hand, when photosynthesis takes place during the day, CO2 is removed from the water column, thus shifting the DIC equilibrium to the left and resulting in the consumption of hydrogen ions. This is why the pH of a planted aquarium will gently increase throughout the day. It's important to understand that in our aquarium, the pH is always changing. Now this change may be subtle and undetectable if tested, say, within the course of an hour, but when taken at a few different time points throughout the day and into the night, differences in pH are very noticeable. A safe pH range in a freshwater aquarium can vary between 6 and 8 depending on several factors. Some species of fish are extremely sensitive to pH and may require a narrower pH range to remain healthy, so don't forget to do your research before buying your fish. Now let's talk about water hardness. We can break this topic up into two main categories. GH, or general hardness, refers to a solution's relative concentration of calcium and magnesium ions. KH, or carbonate hardness, is a measure of the free bicarbonate and carbonate anions, which is also referred to as a measure of alkalinity. Soft water refers to aquarium water with a low GH and KH, as well as having a lower pH. Hard water is just the opposite. It refers to a high GH and KH, and therefore will tend to have a higher pH. Most of the time in natural environments, GH, KH, and pH are all commonly linked, meaning that if the GH is high, so is the KH as well as the pH, and vice versa.
There are several important things of water hardnesses. First, it is used for fish culture and determine the water quality. Second, during the fish spawning and rising fry, the calcium is critical to egg, bones, and tissue development. Third, humans also need minerals to stay healthy. Moving on to the importance of alkalinity, it is used to protect or buffer against rapid pH changes. It is also used to prevent copper toxicity, whereby copper is used as a treatment for algae or parasite. Next, it is to ensure the sufficiency for fish tank inhabits as well as for biofiltration. Next is the importance of pH. pH is used to measure how acidic the level of water, to maintain the proper acidity in many products such as shampoo and medicines, and to detect extent of certain pollutants gases in the atmosphere such as pH of rains.
When you wash your hand, you may feel the effect of water hardness. Depend on the water hardness of your water after using soap to wash, you may have felt like there was a film or residue left on your hands. In hot water, soap react with calcium to form soap scum. This is soap scum. And then when you use hot water, soap I needed more to get your hand clean.